Hello, fellow Scratchers! Have you made a great Scratch game, but felt it was let down by using Scratch's built-in variables for the score or timer? Yeah, we've all been there. Well, worry no more, because today I will be showing you how we can dispense with those and replace them with something a lot more awesome. Oh yeah, come on! The concept is pretty straightforward. We need to have the digits 0 through 9 as costumes of our sprite, and then we add a little code in to handle the rest. And that's what I'm here for. So guys, without delay, let's get scratching. We'll begin with a fresh new project and quickly mock up a simple clicker game. We just need a score variable for all sprites. There it is. And then when this sprite is clicked, we change score by 1. Wow, this is about as basic as it gets, right? We click our cat, and the score increases. Job done! But gosh, it would all look so much better without this boring, generic variable reporter. It's so small and uninspiring. I mean, we could double-click the score on the stage to change how it looks. That's a tad better, but it hardly adds to the excitement of me clicking the cat. No, what we really want is for the score to be large, colourful, in your face, and really funky. The only way we can currently do this is by using sprite costumes. Well, alrighty then. We'll start by making a new sprite. I'm giving mine the name Score. Click to choose a new costume from Scratch's library and search for Glow. Now, you notice there's a whole costume font already made for us. Well, that's handy. Choose the 0 digit first. So that looks pretty cool, much more exciting than a variable reporter. Now we need to import the other 9 digits, one costume at a time. I've copied the word glow into my clipboard so that I can paste it into the search box and save time. However, don't feel you are stuck using this particular font. The tutorial will work just fine if you want to draw your own. That would be super fun and would make your project unique to you. Phew! I've imported all 10 costumes, 0 through 9. Let's center the costume on the stage. Just move the score variable reporter out of the way first. Yeah, that looks great. Now we just need to figure out how to make the beautiful new digit display the same number shown in the variable reporter. Often a problem is not so hard to solve if you can first break it up into smaller problems, and then solve these smaller problems one at a time. Rather than tackling the whole score of 117 then, we'll begin by looking at just the first digit, the character 1. Come into the code tab of our score sprite. Let's start by setting up our sprite. When green flag clicked, go to XY. The current position of the score sprite is pre-populated for us. Great. To help explain what we are doing, I'll bring in a say block from the looks category. And for now, simply say the value of the variable score. Hit the green flag to run the project, and we'll see the full score of 117 displayed. But for now, we only want to deal with the first digit of this longer number. Luckily, we can get the first character using the letter of block. This is ever so useful. Just plug in the score variable and... yay! Out pops the first digit only, the 1, just as we hoped. Right, that was the first hurdle. Now we need to translate this into a costume, the costume for a digit of 1. Look in the costume tab. See how all the costume names begin with the word glow and a hyphen, and then the single digit the costume represents, like a 0, 1, 2, etc. Well, that makes selecting the right costume super easy. All we need to do is join together the word glow with a hyphen with the digit we want. So back in the code, and pull in a join operator. On the left we enter the word glow hyphen, ensuring to keep the uppercase G, and then on the right drag in the letter 1 of score. Do you see what this is doing? Put it all back into the say block and run the project. And now you can see we've managed to construct the full name of the costume, glow-1. Great, so instead of saying the costume name, toss in a switch costume block and move the join in there. The old say block can go. Awesome, let's give it a test. Yes! As long as you match the costume name exactly, including the uppercase and lowercase letters, you should find that the costume has switched to the correct one. It's worth trying it with some other score values, just to make perfectly sure it's working as expected. And of course, I can click on the cat and the score variable goes up, but I do still need to click the green flag afterwards before this large digit updates. Now, once the score increases to 10 and above, well, we come undone because we need to look at the next part of this tutorial, increasing the number of digits displayed. To accomplish this, we will need to make copies of the first digit sprite, and for this we shall use clones. Bring in a repeat block to surround the switch costume. Now for starters, we'll have 4 clones, so enter 4 in the repeat loop. After switching costume, create clone of myself. But before we loop around and continue creating more clones, to prevent all the digits being cloned on top of each other, we need to move this sprite out of the way to the right. Change X by. We don't know how far to move it. The size of the numbers will change depending on our costume and also the current size of the sprite. A size of 200 will need twice as much room for each digit. Right then, let's experiment. Try moving right by the size reporter of the sprite itself. That would move 100 pixels when we are at the size of 100. Right, well, it's good to see the clones are appearing. But these digits are far too spaced out. In fact, we could fit 1 digit in between each of these clones. That's actually quite a useful measure. Perhaps we should just half the distance we are travelling. Change X by half the distance then. That is size divided by 2. Give that a test. Okay, yes, that's looking much better. So, depending on the costume you've used in your project, you may need to tweak this number 2 to make the spacing work for you. So we have our clones, but they all show the same value, be it 1111 or 5555. This is because each clone is still set up to show letter 1 of score. What we need is for each clone to be assigned a different digit position for it to display, the first, second, third letters of score. But before we deal with that, did you notice that although we have created 4 clones, we are seeing 5 digits? Yeah, that's because the last digit is not a clone, but the original sprite. We should deal with that first so it doesn't confuse things. Drop in a hide block after the green flag is clicked. And then, when I start as clone, show. This way only the clones will display, right? Give that a test, and there, just the 4 clones are showing. Now we have the when I start as clone hat block. We can move this switch costume over to here. This puts each clone firmly in control of switching its own costume, which I like. But, as we just noted, they are all looking at letter 1 of score. To identify which letter of score each clone should represent, we'll make a new variable and name it index. Make sure to switch it to for this sprite only, as each clone needs its own value for this to work. We begin by setting index to 1, just before our repeat loop. And then change index by 1, as the last instruction in our loop. We can see this in action by bringing back a say block. Drop in the index variable and give that a run. There, see how each clone is reporting its own index, starting at 1 and counting up. So that's perfect for pulling out the right letter from our score. Simply drop the index variable into the letter of score block. Okay, we need to test this baby out. Set score to 4321, 4321. Click it to set the value and then run this project. Oh wow, yeah, look at this, 4321, exactly matching the score variable, but in beautiful large vector letters. So delete that say block, and there we go, so cool. And if I click the cat to increase the score, still not updating the costumes automatically. We don't want to have to hit the green flag for this any longer. No problem. Drop in a forever loop around the set costume block. And then make sure to restart your project This ensures the new clone forever loops start running, and now click that cat. Woohoo! Yes! This is more like it! Our costumes are now synchronized with the score variable, and I am loving it. Also, if we double-click the score reporter to change it to a slider, and right-click to set the slider's range, setting a max value of 9999. Now we can slide this around and see the score tracks this too. Everything is working great. So are we done here? Oh no, look what happens when the score is dropped down to 0. Ah, bummer. Okay, so what has happened here? Well, the first digit is a 0, that's correct, but the rest, that's a mess. Equally, if I increase score to say a 3-digit number, the first 3 digits are good, but the last one, nope. The problem we have is that we don't have any sense of a blank digit. What do I mean? Well, look, if we use the letter 1 of block with the number 100, obviously we get a 1 back as the first letter, and letters 2 and 3 are both zeros. But what about letter 4? Do you know the answer? Yeah, it's blank, the empty value, because there is no 4th letter in a 3-digit number. Well, knowing this gives us power. Come into the costume editor, see the first leftover blank costume here. If you don't have one, then don't worry, just create a new one. The order won't matter either. So we start by grabbing the costume name from the other costumes, glow hyphen, but not the last digit. And then we use it as the name of the blank costume. That's right, just the start of the name, with nothing after the hyphen. So this costume name will match any blank digits, that is, any letters past the end of the score. Shall we test that out? There you see, we are down to 3 digits. Yes, the 4th clone is still there of course, but it's now using that blank costume, so we simply cannot see it. We can drag the slider back and forth and clearly see this working a treat. Good job if you have got this far. Okay, I can reach the number 9999, but what about 10,000 or 100,000, a 6-digit score? Well, change the slider range so it can go to 999999. Oh boy, that is not good. 4 clones gives us a maximum of 4 digits, and after that we are in trouble. But not an issue, back in the code. Up the repeat loop from 4 to 6. Ta-da! Well, that sorted that. Now we just have the problem of the score trailing off the screen. Perhaps we'll move it over to the left, like to here? Just enter a negative value into the go-to-x at the start here. I'll try minus 180. That's not so bad. It all fits now, so as you see, we can position and size the score in any way we want. I'll just try a different size. Hold on. What's up with this? Scratch is refusing to let me size the score sprite. That's confusing. Let me try using a set size block instead. Set size to 50. Run that. Huh, no way! It's still not working. Look, size is still 100. Okay then, I've guessed what's up, and it's silly. Ha! Look, in the Costumes tab. The selected costume is the empty costume, and this has a size of 0 by 0 pixels. And as such, Scratch is preventing us sizing the sprite down at all. If we switch to any other costume before the set size, then now I bet you this will work. Yes, oh my word, how Scratch likes to test us, right? Well, at least we know how to solve that one now. Okay, back to positioning the score. Now that it's so much smaller, we could move it over to the right again for it to be more central. Perhaps set X to minus 80? So that looks okay for the longer 6-digit score. But what bugs me is that when we drop down to a shorter, smaller number, well, then the number looks like it's far off to the left of centre, and that's not so nice to look at. Indeed, our number is left aligned, and although this can be perfect for some layouts, I would also love to show you how to make it centre aligned, as that can look even better when your score is front and centre like this one. Now, the way we center align text is to take the text we have generated, find its full width, and then move all the text left by half of that width. And that's it. It's centered. To code this, we are going to have to do a little maths. So here are our 6 clones, each with an index variable 1 through 6. To position them on the screen, remember that the width of each digit for me is given by size divided by 2. So we could set each clone's x to index multiplied by size divided by 2. That would give us our letter positions as follows. But notice that because sprite costumes are centered, that the first digit appears offset half its width to the right of center. We can fix this first by subtracting half from each index. That will move them half a digit to the left. And now to center them. The length in digits of our number is 3. So we half 3. 3 divided by 2 is 1.5. And then we subtract this again from index. Okay, not so hard. Maybe. Let's code this up. Start with the setX block. And we need the index variable and a size divided by 2. These we can multiply together and plug into the setX block to give us an initial positioning. If we run that, then we get a simple left aligned position as before, be it a little right of center. So now for centering. We subtract half, that is 0.5, from index to allow for the center alignments of the costumes. Then from this we subtract the length of our score variable. But we only want half of its length, so bring in a divide, and we want to divide this length by 2. There, pop that back in, and then the whole expression wants to be placed on the left here, multiplying everything by size divided by 2. Excellent! That's quite a long sequence of blocks. But does it work? Run the project. Nice! The 6-digit number looks to be centered, but we'll only know for sure if we try a shorter score with less digits. Down to 5, yes. To 4, oh yeah, marvellous. This score is centering perfectly now. Just in case you wondered, if you wanted to position this text elsewhere on the screen, you can easily insert a change x by after this go to x to offset it elsewhere, and the y you can set as normal. We can also confirm it still works with larger sprites too. Yeah, great. Now we are almost done. I suggest we speed up the initial cloning to avoid any unnecessary flickering. So make a new custom block named setup, and we run without screen refresh. Move the entire green flag script stack under the new define block, and then replace them with your new setup block. All the digits will appear as soon as the project runs. Schmokin'! So that's everything that I really needed to cover to ensure you can make some amazing projects with this. But before we finish, I would really like to also just tag on one extra thing that looks oh so cool. A little animation. Find the when I start as a clone script. We'll start by making a new custom block, naming it change costume 2. And then add a new text input called costume. We want to use this in place of the switch costume block here. So move the join into the input of the custom block, and the actual switch costume can move down into our define change custom block. Finally, link up the switch costume by using the costume input variable from the define block. Good, so we've rejigged the script, but it does just the same thing as before so far. But now, within the custom block, we are given the new costume name before we actually have switched to that costume. This will allow us to check whether the costume needs to change or not. So if not, costume equals costume name, then switch the costume. Again, this does not change anything, but it opens the door for us to take another action when the costume does change. And what we'll do is set size to 120. If we test that, you'll see only the changed digits grow bigger. But to complete this effect, we need to quickly return them to their original sizes afterwards. Place a change size by after the set X in the R forever loop. Oops! Stop the project! And a nice smooth size change can be given by multiplying with a subtract. Then place the current size on the right and the target size on the left. That gives us the difference in size. Then multiply this by a fraction, like 0.2, to slow down the animation. And that's it. We are ready to test. So firstly, drag the slider on the score variable. Oh man, that is cool. See how the letters pop out as they change, and then sync back to where they belong. I like that. Let's go full screen and try clicking the cat. Oh yeah, this would make a sweet effect for any clicker game, don't you think? And I wonder what other special effects you could think up that would take your games to the next level. And I am finishing now, honest. Almost. I just wanted to answer the question that you were just thinking. Can we extend this number engine to include words, letters, and symbols too? Yes, we can. Simply go into the costume editor, import the characters you are interested in. That could be quite a lot of them, so be warned. And then you just set score. Perhaps we should use a different variable name at this point. Set score to a word like bed. And then 401. Okay, so that didn't work. Why not? Simple. Because costumes are case sensitive. We need to use uppercase letters to match the costume name letters. Try again with BED, all uppercase. And there you go. We have at the start of a text engine. Exciting idea for a further tutorial, perhaps. And okay, I've made a Scratch Studio for this tutorial. You'll find a link for it under the video. If you manage to make something with this tutorial or use it in one of your own games, I'm sure you will, then please don't hesitate to submit it to the studio. I'd love to see what you've made. And with that, we are really done. If you enjoyed this video, then smash the like button and don't forget to subscribe to the channel so as not to miss any future episodes. If you feel you could support the channel further, then please do consider joining the channel membership. There are perks for all levels, including some awesome custom emoji, priority replies to comments, early access to videos, and for educators and top supporters, access to the projects themselves. So good. Well, thanks for watching. Have a great week ahead and scratch on, guys.